GG11 is the largest and most capable low-energy MCU in the industry. From a processor and memory perspective, it includes a Cortex-M4 with a floating point unit, capable of running up to 72 MHz, with a very large on-chip memory footprint, including up to 2 MB of flash and 512 KB of RAM. This enables a very large code space, over-the-air update capability, more debugging capability, data logging, rich graphics, you name it. But even with these capabilities, we've kept power very low. It has a 77 microamp per megahertz run mode, 1.6 microamps deep sleep mode with fast wake up, a wide operating supply range, and unique autonomous sleep mode capabilities are built into almost every peripheral on the chip. We offer a wide range of packages covering QFN, TQFP, and BGA technologies from 64 pins all the way up to 192 pins for very high I/O applications. Let's turn now to the block diagram for the GG11. This block diagram includes a view of the chip's low energy architecture. Each peripheral is color-coded to indicate which energy modes it can operate in, from run mode in orange to sleep modes in varying shades of blue. Notice that the majority of features on the chip can operate in the low-power deep sleep modes. I'd also like to call out several key new features. On the interface side, we have 10100 Ethernet, a quad and octal SPI controller, an SDIO interface, and dual CAN bus. The analog feature set includes dual ADCs, both voltage and current DACs, op-amps, comparators, integrated CapSense, and our low-energy sensor interface called LESense. From a security perspective, we have hardware ciphers as well as a hardware NIST-certified true random number generator and a security management unit to allow software control of fine-grained peripheral access. Let's revisit those three key functions of most IoT products. We'll start with sensing. GG11 can go into deep sleep mode at single-digit microamp current and then use an array of timers, external interrupts, or analog modules to trigger when you actually need to wake up and take action. LESense, for example, gives you the capability to measure resistive, inductive, or capacitive sensors autonomously. If your sensor requires excitation, LESense can do that by driving I/O or turning on a DAC output. In turn, the resulting sensor input signal can then be measured and the result used as needed for the application. For example, it can be compared with a threshold using the comparator and then trigger further action, or stored in memory using the DMA. There are also several peripherals capable of operating all the way down to stop mode. Touching on just a couple of these, the ADC enables very flexible analog signal monitoring at low power, and the CapSense interface includes a wake on touch capability that provides highly robust low power button monitoring. With the sensor data acquired, let's move on to process and control. GG11 allows the system to continue operation autonomously with a low-power peripheral communications network called PRS, which is short for Peripheral Reflex System. PRS, in combination with an intelligent link DMA controller, allows data to be moved amongst peripherals and memory. PRS enables much to be accomplished without needing the ARM CPU, but in those instances where it is needed, for example to run a sensor fusion algorithm, GG11 provides a fast 3 microsecond wake-up from sleep. With data captured and processed, it's now time to do something with it. For example, log it for future use, send it to the cloud, or display it to an end user. The 2 MB of embedded flash and both quad-SPI and SD-MMC card interfaces for external memory provide ample space for extensive data logging. With a total of 18 serial interfaces spanning from UART, SPI, I2C, Ethernet, SDIO, CAN bus, and USB, the wired and wireless communication options are almost endless. And you can locally display data to a memory LCD or to a segment LCD using our new low-energy segment LCD driver called LELCD. LELCD includes a patented charge redistribution technique that reduces power consumed by the external LCD module by up to 40% when compared to what that same external module might consume if connected to a standard LCD controller. Finally, let's talk about security, a hot topic in IoT today. GG11 offers a robust security infrastructure to keep data and proprietary IP safe and secure. GG11 provides a secure execution environment for data processing using both the MPU and SMU. Onboard hardware crypto accelerators enable secure transmission and receipt of data off-chip. And finally, dual watchdog timers provide redundancy for safety-critical applications.